All right, we're going to pull back the curtain on one of JavaScript's most misunderstood and, let's be honest, sometimes frustrating features. It's kind of like this secret engine that can make your code feel like it has a mind of its own. And it all starts with a simple but very strange question. So take a look at this. An empty array plus an empty object. What in the world do you think that equals? In a lot of other languages, this would just be an error. Game over. But in JavaScript, this is a totally valid, if a little weird, piece of code. And it has a logical answer. By the end of this, you'll know exactly what that answer is and, more importantly, why. But before we dive into all the weird stuff, we have to go back to the beginning and ask, why does JavaScript even exist? Well, it was created to solve a really specific problem. Back in the day, websites were basically just static documents. You could read them, sure, but you couldn't really do anything with them. To really get JavaScript's role, I love this analogy. Think of a website like a person. HTML gives it structure. That's the skeleton, the nouns. CSS makes it look good. That's the clothes and the style, the adjectives. But JavaScript? JavaScript is the nervous system. It's the language of action. It's the verbs that bring the whole thing to life. Think about a simple calculator on a web page, right? Without JavaScript, those buttons are just for decoration. You can click them all day long. Nothing's going to happen. But with JavaScript, suddenly those clicks mean something. They perform calculations, they respond to what you do, and they make the page genuinely interactive. Now, to make all this cool interactivity happen, JavaScript needs a way to remember things, like the numbers you're typing into that calculator. And that brings us to one of the most basic building blocks in all of programming. And that's the idea of a variable. It's really not a complicated concept. Just think of it like a labeled box, a container, where you can stash a piece of information. Whenever you need that info, you just call out the label on the box. Simple as that. So what kind of information are we putting in these containers? Well, for the most part, it boils down to these three basics. We've got numbers for doing math. We have strings, which are just any kind of text. And then we have Booleans, which are basically just simple on or off switches, just true or false. Okay, so we've got our building blocks. We can store numbers, text, true/false values. This all seems perfectly normal, right? But what happens when these different types of data start to, interact with each other? This is where the magic and, sometimes the madness really begins. And look, that's not just me being dramatic. It's a feeling shared by pretty much every developer out there. JavaScript is incredibly flexible, and in its attempt to be helpful, it can sometimes produce results that seem to, defy all logic. Let's look at a super common scenario. You have a form on your website, and you ask a user for their age. They type in 25. Now, in your code, you want to figure out their age next year, so you take that input and you add 1. What do you get? You'd think 26, right? You get 251. Not 26. So what on earth happened? Well, the key thing to remember is that user input from a form is always a string of text. So JavaScript saw you trying to add a number, 1, to a string, 25, and it decided to help by just meshing them together. This helpful behavior actually has a name. It's called implicit type coercion. Let's break that down. Implicit because it happens automatically behind the scenes without you asking it to. And coercion because JavaScript is basically forcing a value to change its type to make some operation work. This right here, this is the heart of all of JavaScript's weirdness. Now, it might seem like total chaos, like you have to memorize a giant, complicated chart of all these strange outcomes, but you don't. The secret is that all of this apparent randomness is actually governed by a very small and very consistent set of rules. And once you know the rules, you have the compass to navigate all of it. And here is the big secret. All of JavaScript's weird behavior, all of it, boils down to just 3 possible conversions. That's it. Just 3. So every time JavaScript performs this implicit coercion, it's trying to push a value into one of these 3 boxes. It's either trying to turn it into a string, into a number, or into a Boolean. So let's just look at the rules for each one. Okay, rule number 1 is the easiest one. If you use the plus operator and either one of the things you're adding is a string, JavaScript is going to convert the other one to a string and just stick them together. This is called concatenation, and it's exactly what happened with our 25 plus 1 example. Now, for most other operators, we're talking subtraction, multiplication, division, or even comparisons like greater than, JavaScript does the complete opposite. It tries its best to convert everything into a number. And that's why the string 6 divided by 2 actually gives you the correct answer, 3. And for loose equality, true gets converted to the number 1, so true equals 1 ends up being true. And finally, the Boolean rule. Now, this one is mostly just a little bit of memorization. There are only 6 specific values in all of JavaScript that will ever turn into false. We call them falsy values. And that includes things like nan, which stands for not a number. Everything else in the entire language, and I mean everything, including an empty object or an empty array, is considered true. Okay, so we know the 3 rules, but why is this so important? This isn't just about answering trivia questions. Understanding these rules is a truly fundamental skill that separates novice coders from pros. Honestly, it's like a developer's superpower. This brings us to probably the most critical place you'll use this knowledge. JavaScript has 2 ways to check if things are equal. The double equals, what we call loose equality, will use type coercion. So to it, the string 1 and the number 1 are the same thing. But the triple equals strict equality does not coerce. It checks both the value and the type. Using triple equals is almost always safer and leads to way more predictable code. And it's really no surprise that a huge number of bugs in JavaScript programs come from these unexpected type conversions. When you understand the rules of coercion, you can see these problems coming a mile away and write stronger, more reliable code because you're not getting tripped up by the language trying to be helpful. And this is the main takeaway. The goal is not to memorize that array plus hexadecimal becomes uString bracket object. The goal is to understand those 3 simple conversion rules, because when you see a weird example, you can use those rules as your compass to figure it out from scratch. You understand the system. And let's be fair, while it can cause some major headaches, type coercion isn't all bad. Once you really get it, you can start to leverage it. It can be a handy tool that lets you write shorter, more concise code, as long as you and the other people reading your code understand what's happening under the hood.
So let's end with a little challenge. Based on the rules we just went over, what do you think this evaluates to? Think about that plus operator. What's the first thing it's going to do when it sees that empty array? And then what happens when you add that result to null and then add that result to the number 1? It's not magic anymore, it's just a system. So, can you solve it?